How's it going, eh? My name is Ethan, and today I want to show you some audio work I've been doing in Unity. It's the workings of a middleware, but it's got sound events, material switches, RTPCs, a few things like that. Has an AudioManager for sort of managing like voices and tracking like stealing and things like that. And I think it's kind of cool. So let's look at it. So here we are, actually inside of Unity. This is my demo. So what I've got is a very basic scene going on here. I'm just using Unity primitive shapes effectively. I've got a concrete wall, concrete floor, wooden crate, and these metal air ducts. And then I also have this little explosive mine, which will serve as both an interesting demo in itself, but again, as like a vehicle to sort of show off this pseudo middleware that I've got going on here. So those were some of the explosions that the mine will make in the full context of everything. Now there's quite a lot to break down there because there's a lot of sweetening stuff that's sort of happening with the base explosion layer. So what we've got going on here is we have the base explosion, and the base explosion has a material layer which sounds like this. And that's just the concrete. So this could be anything. If we're on dirt, maybe something more gravelly, something like metal, right? We could have different layers that go with that mine explosion. And we of course have the actual base layer. Just a very, very simple explosion that has no real direction, just as the art style has no real direction. And then we have shrapnel, which is one of the big things that really helps this. So we've got a variety of like swishes, things flying past the camera. We've got things hitting like the concrete, the wood boxes, any type of metal ducts, if we can get a nice metal one. Got some metal in there. Nice. It's kind of random though. And then of course you got really tiny little like sounds for these little fragments that come around. And it sounds really nice when you get like, sometimes you get a lot of that metal there. It sounds awesome. Like ding of like the shrapnel just hitting it like perfect. And then of course we've got these other things, which I call them resonators. I'm not sure what else I would really call them, because you know, if you're rattling a box from like an explosion, you're both literally shaking the box, and there's a component of like box that's also going to resonate, right? Like a guitar or even a vent. So I just call it a resonator. So that sounds like this. So there's some more metal sounds, and there's some like actual like wooden sounds. So for example, we could solo the boxes, kind of what the boxes sound like there. So that's like kind of the boxes just shaking a little bit. Then we've got the actual air ducts here, these little metal ones. Yeah, just kind of like some rattle from those, right? Combine those together. And so this is all like kind of the stuff that goes on top of the actual explosion. Okay, so let's actually get into the nitty gritty, the details. So what's going on here? So audio clip by itself, very simple, very useless. You can attach it to a script, but then you're gonna have to add script to that code. Code is gonna be like really big for like each script. That has nothing to do with audio, just to play audio. So instead of doing that, we can pack a ton of information inside of something like an AudioManager, maybe an audio voice, and then also like a sound event, right? So three kind of main things. In this demonstration, I also have a material switch, which is effectively just a really tiny wrapper for the sound event to allow me to link up materials and events and stuff, right? So what does a sound event look like? It looks like this one over here. If I have more than one object right now, by default, it will just randomly select one and act as a random container. And if I have one object, it just obviously plays that one object over and over again. We can set lots of information here: stealing, voice limit, random start, looping, things about distance, spatialization, pitch, all the stuff, literally everything that the audio source would allow you to modify. We can set it all here in the sound event, of course. So we can set that before, and in some cases, like for example, play ahead, set that immediately after playing the sound through that audio source, right? I even have RTPCs here, which are great. RTPCs are just the cornerstone of high quality audio implementation, of course. So I have RTPCs in here, which just has a value parameter, a min max, pitch, volume, and then a curve. This is what the code for this looks like. So an RTPC is just a struct, and then in here we can put down tooltips, put down all sorts of things, but most importantly, parameters. So I have, later on, I can use a switch and kind of figure out what to do with this RTPC. And then, of course, the animation curve itself, and then what is minimum and maximum are going to be. It's worth noting that you can't really make a animation curve. Like, it's not a good idea to try to actually drag your animation curve out to be like 5 instead of a 1 at the max point. So when I draw this, I'm working on a 0 to 1 scale. It's just 100%. And then we just remap that later using some maths. Maybe that wasn't very clear, but you know, just a classic 0 to 1. And then later we can remap it so that our min and max values actually do line up with this graph. And then we have all of our information here. Then at the bottom, we can put some private information that doesn't really matter when setting it in the inspector, but this could be used code to just pack additional information into the sound event when it goes through the audio manager. Let's look at the material switch, which could just act as some sort of little wrapper for this. So all it is it can hold a list of these material lists, and then a material list is a struct that is a physical material plus a sound event. We pretty much would just run through on this get sound event. We just run through this material list, and then we would say, hey, does something match this physical material that I'm giving you right now? Okay, let's get the sound event out of that. That's it. It's just that simple. So let's see what a prefab using things looks like. It's like this. So I have, for example, a detonate event, swish event, shrapnel, and a mine switch. I'm using 4 different things here. And inside of the code, we can see that the way I'm using this is I have a SoundManager instance play, and then I'm just putting the detonate event in, and I'm putting it in there with the game object transform so that we have like owner to identify with that object. And then we have the second one, which puts just the mine switch in. We're using that method to get the sound event from the material switch, which is what the mine switch is. And then we're using a returnable method, and that will return a physical material using a raycast. So it shoots down from the mine, grabs underneath it, and then we use that on play of the material layer. We just grab the material and then we send that out. So here's something that actually uses both the material switch and the RTPC. So this is shrapnel, gets fired to the mine when it explodes. It's very fast. It's affected by gravity. It's kind of like an arcing raycast. When it hits something, we can get the sound event based off the material that we hit because we have a material switch in here, and that is what's being done. Then I'm taking the sound event, going through its parameters, grabbing by index the RTPC struct, and then I'm modifying that struct and then replacing by that same index inside of the sound event that struct with the struct that I've modified, because we're just not allowed to just go and say, what about this, right? We do sound event parameter dot value. We can read this, but can we set this? We cannot modify the return value of this because it's not a variable. Okay. So we have to do it this way. And then when this is all done, we can go ahead and package that up back into the sound event, technically is what we're doing. And then we just play it. This is our sound manager. We can go ahead, we can get an instance from it on Awake. So we can call this, of course. We set up a voice pool to stash all of our game object voices inside of this nice little folder within the sound manager. So it's all nice and contained. We then have a couple different constructors here to reuse this exact same method instead of like copying and pasting this entire method like a psychopath. We could just keep doing this, right? And have all these different constructors with repetitive information, but I like to do it where we do it this way. For example, I have this option called attach to owner. So I can either include this in the constructor when I call it, or I cannot, and then I'll just go ahead and assume that we're not going to attach to the actor by default, right? Maybe we just want to play it just once at that location. We also have a list for active voices, which is very important, and a little config. With all that said and done, we can actually get into playing the sounds here. So here I have this play internal. We pass through that sound event, scriptable object, transform an owner, and then this Boolean right now. It's probably pretty sloppily set up. Cool. So what do? First thing, do we even have an audio clip in the sound event? Because if we don't even have an audio clip in there, get out of here. Like, we're done. We're not playing no more, right? We just return. We can throw out a debug message, say, hey, what the heck, man? Another cool thing is that we can actually check stealing. So down here, we pass the sound event through. We create a temporary list. We say that it is playable right now, but then maybe it's not playable in a second, right? So then we'll go through all the voices and active voices that are based off this sound event. So how many of these sound events are right now playing in the active voice, whether it's even that tiny bit of tail going on, right? We go through, we grab all of them out of the list, add it to this temporary list. So we have a list that's sized to just those voices that we want. Then we go through here, we check the voices count. This is the stealing count. We compare this against the sound event's voice limit. And then we go ahead and say, are we stealing oldest, newest, never? We do different things based off that, right? And then we return this Boolean back that will pretty much say, oh, I can't play because I'm never allowed to steal anything and we're at the voice limit. Or, oh, I actually can play because I can steal from the oldest. So I'm going to go ahead and grab the oldest voice and I'm going to steal from it, right? Because this is an option inside of the audio voice. We say, hey, we're stealing you 200 millisecond fade out. So we go through that. And then now over here, we set the owner of the sound event. We set the position of the sound event just in case it wasn't set up before. And then we can go ahead and get a voice object, which is instantiating this audio voice that we have from the config, which is a little prefab. And then we have our actual voice, which is the voice object component audio voice. So that's the script that's on there. And then if we want to attach to owner, we can attach to owner this way. The next thing we have is we set up the voice object parent to be inside of the voice pool, which ironically breaks this previous behavior. So we would want both of these to work together. This just wouldn't be done inside of the SoundManager. And then we set the name based off the sound event's name, and then we add it to active voices. And then there's some information here we could set for a global cooldown that I didn't set up, and we play. And here we have the audio voice where many logic done-ing, you know? So, and here we just set up some local variables. What's the audio clip? What's the event, right? So here, audio clip, get random clip. We can go see get random clip is effectively return a random range from 0 to the length of the list of audio clips. So this will always return index 0 in the case that there's actually not any extra clips, which is exactly what I would want. And then before we bother running any code, we want to try to eliminate some easy like optimizations here. So for example, we're going to go ahead and generate a random percentage value and say, is it greater than the sound event probability? Destroy the game object, return. And then we also then check random start. We get the audio clip length, some information like that. And then we go ahead and we pretty much set based off of basic information on the sound event scriptable object. Here's a case of a remap function where I'm taking -12 and +12 floats, and I'm remapping it to 0.5 and 2. Half the play rate would be 1 octave down, double the play rate, 1 octave up. And then we're applying this remap to the pitch of the sound event. Over here, we're going to check for RTPCs. So we're going to go through and say if our RTPC count is greater than 0, we must have one in the list. We're going to go through, we're going to get their mod values, and we're going to go ahead and check, is it for volume? Is it for pitch? You know, we just keep coming here, add case, add case, add case. And here we do some remaps. So for volume, if I have a float range from 0 to 30, I'm now going to map that into 0 to then what the maximum volume of the sound event was. And then we're going to use parameters value to move that. Then when we're done, we're going to change the audio source's volume with a parameter value, and we're going to evaluate that across the curve. Now, technically, this actually shouldn't be here. This should be in an update tick, because what if I want to change this in real time? I think the best option would probably be to make a coroutine for each individual RTPC and then track its values based off of the parameters. So over here, we get a random pitch by using the Unity Engine random range. We take the min, the max, and we add that to the pitch that was set in the sound event. So that way we can have that range follow a pitch offset, and then we will just clamp this to -12 and 12 because all this really supports at this moment. And then we take the audio source and we set its pitch. We check, do we have the play and fade out? If we don't, you know, we actually just play the audio event. Playing the audio event just looks like this. We set up some time. We check delays. We make sure that we were waiting, that time is actually going to be less than the delay time before we go and play things using a little setup like this. And then we would play the sound. If we had something a little bit more complicated, like the play and fade out, and here, again, I should also be including the delay, but we would set up a time and we would say, while the time is actually less than sound event.delay. Nice. I did set that up. We play the audio source, show our debug text, whatever. Then we set up a timed destroy for the object to make sure it dies when it needs to. Reset the time to 0. Use the time again to check if we're greater than body duration. And while we're still within the body duration, we just keep returning and counting out of it. And then when we've counted out of it, reset the timer again. And then here we actually apply a fade out. We do the same time counting loop, except we're doing a math lerp on the volume to just sort of like S-curve the volume out to just get the fade out. That's it. Here's the setup for stealing inside of the audio voice. We just say, yes, we're stolen. And we say, we remove this from the active voices list. We then come over to here and we make this thing called remaining time. And this would equal the audio clip length minus the playback time. So then if it turns out that we've actually been playing for too long and our remaining time is too little to respect our fade that we've asked for, maybe it's like a 5-second fade, but we only have 4 seconds left. In that case, then we'll actually use our remaining time as the fade out. If we only have like a second left, like the fade will get smaller and smaller and smaller. We do that and then we run a coroutine to just, again, do all the fade logic. That's it. That's the entire project. Yeah, so that was the breakdown of my rudimentary middleware inside of Unity, as well as a pretty brief overview of the technical implementation for the mine. It's very interesting that you can do this sort of stuff in Unity. For work, I've experimented with like using property drawers and then actually taking the GUI and making like custom slots. One small example, if you're trying to make tools for your designers to implement audio really quickly, you of course want to make really good GUI that's like clean and very extensible and won't like be really like overwhelming and in the face of people that don't need like advanced tools all the time, maybe just sometimes. But yeah, thanks for watching.